Hey guys, welcome on a new tutorial series, and this one is finally about crystals. So I will tell you more at the end of the video how I intend to unfold my plan for the full course. In a nutshell, I'm going to explain the process of making the fibrous malachite I did a while ago, mostly because I'm convinced the different techniques used to create this mineral can be a great learning material for beginners and intermediate users of SideFX Houdini. We're gonna talk about procedural modeling operation with surface operators, mesh fracturing, geo to volume displacement, hair and fur to generate the fibers. You name it, it's a lot to cover. We'll start with the first part, the procedural crystal setup, which is a free tutorial on my YouTube channel for you guys. If by the end of this video you learn some valuable information and wish to learn more, I invite you to get the full course on my Gumroad. More about that later. In the meantime, let's just enjoy some procedural fun. Alright, let's start. So we're gonna create a geo context, and inside we're gonna create a platonic solid. We need to change the source type into dodecahedron, like so, and we're gonna create a tube. So we need to turn that into polygons and end caps. Let's reduce the columns to 6, since crystal mostly got like 6 sides, and we can tweak the radius and the height. Now what we can do is pull in this main shape. Just before that, I'm gonna copy the parameter of the height and paste it as relative reference in center Y divided by 2, just so it stay above the ground. So now if we boolean it, we get this shape. We need to turn the operation into intersection. So that's pretty cool. Now we would need to tweak the position and rotation of that platonic solid. So I like to use a match size and plug the second input onto the tube. Now as soon as we change the height, well, the dodecahedron is following the tube. I think we should probably turn off the scale to fit because the shape is just too weird. And yeah, let's add a transform node. In there, we're gonna center the pivot first with $CEX, CEY, and CZ. And as soon as we change the rotation, we get some cool shapes. So big shout out to the guys from Untagma for showing these techniques in their tutorial. It was very helpful to get a decent base. And then I kind of like to make things a bit differently to fit the needs of the malachite look. So I'm adding a group that I'm gonna rename top, and I'm gonna isolate the top face by normals, like so. And let's copy that group. I'm gonna call it bottom. This time the direction should be -1 to isolate the bottom face. And let's drop a transform. So I'm gonna call the top group, and as soon as we change the translate, we can control the height of this crystal. So let's call it height. Also applying some colors just to remember where are the key control of the setup. So this one's gonna be the rotation shape. Okay, now it's pretty much time to fracture this guy. So let's drop a Voronoi fracture and a scatter. So the scatter is gonna be like the impact point, and let's reduce that to something around 20 for now. We should plug the Voronoi on the height, and let's plug the second input onto the points. So if we drop an explode view, we can see what's going on with the crystal. So there is a little bug of display. I have to leave the geo context and come back, and it's fine. As you can see, if we start to increase the amount of point, we also increase the number of chunks. So in that case, we're gonna leave that something around 17 for now. That look like a decent amount. And well, there would be this option to disable the interior. Personally, I'd rather keep it for now, just in case, and just blast them. We just need to plug the explode view on the blast, and yeah, the inside faces are gone. So that's good. Let's move on. We're gonna generate some clusters now with the cluster point node. If we try to change the clusters parameter, we increase or decrease the amount of cluster chunk that we're gonna get. So I'm gonna drop an attribute promote, and we're gonna promote the cluster and the CD attribute, and we change the class to primitive. So by changing the promotion method to first match or last match, it's gonna propagate the attributes color and cluster onto the primitive. So now we got some sharper result, and we can play with the clusters amount and the number of points that we have in the scatter. I usually like to uncheck relax iteration so that the position is a bit more random and we get some different size of chunk, so that always help. So let's see. We could also control the amount of cluster based on another scatter point. So same deal, we're gonna decrease the total count and uncheck relax iteration. So what's bothering me is that the edges are very vertical and sharp, and just need to find a proper setting to get some broken up chunks. So that's not too bad. Let's reorganize a bit the graph. We're gonna create a null and call it crystal base shape. We could also select a bunch of nodes and create a network box, like so. So it's look a bit cleaner. I'm gonna call this one cluster pieces, and that one's gonna be crystal base. All right. So back on our clusters, it's time to do some operation with that. We're gonna create a null and call that crystal cluster. So I'm gonna blast the top face for now, and we're gonna simplify it to one point. So I usually like to use a assemble node and create packed geometry, like so. If I plug a add node and delete geometry but keep points, it's just isolating one point, which is usually the center of the geometry. So this point's gonna help us to compare the position of the cluster. So we're gonna create an attribute with an attribute wrangle. So that's gonna be a bit of basic vex. Let's create a float attribute called poseref, and it's gonna be equal to at pose.y. Like if I check out the spreadsheet, the py is equal to or poster. Well, no, that's poseref. Yeah, that's better. So we're gonna do the same for all of chunks. Let's drop a for each named primitive, and if we check out the first iteration, well, we notice we need to rename the piece attribute to cluster, because in the cluster point, that's how the attribute was called by default. And now it's working pretty nicely. So I'm just copy pasting the nodes that we have. In that case, we need to fuse the points before assembling. Otherwise, we get 2 points instead of 1. That's better. And we're gonna copy this wrangle, paste it after the add node, and this one is gonna be called at pose cluster. Same here for organization's sake. And we're gonna transfer the attributes on the main chunk, like so. And so distance threshold, make sure that the value is high enough so that all the points are gaining the value that you are transferring. Otherwise, well, you can get nothing. Okay, so that's good. I'm gonna make a subnetwork out of it so that it's not taking that much space. So I'm gonna call that post cluster attribute. And let's transfer the poseref attribute that we have. So same deal, in points called poseref, and increase the distance threshold. So all our attributes have been transferred onto the cluster. So that's great. Now we're gonna start manipulating those attributes to control the extrusion of this cluster. So I'm dropping another attribute wrangle, and we're gonna create an attribute called extrude, and it's gonna be equal to at pose cluster divided by at poseref, like that. And if we check out the spreadsheet output, we got an extrude attribute with values between 0 and 1, and if it tends to go toward 1, it means that they are higher in terms of position. So I'm converting this attribute into a detail with an attribute promote, and I'm gonna call it inside the poly extrude. So let's use the detail function with attribute promote 2, and we want to call the extrude attribute, and that's what we got. So the extrude is a bit too much. We're gonna create a multiplier, so let's put that in parentheses, multiply by control extrude mult. So if we click on plus, well, it's not creating the parameters, mostly because we shouldn't have any space like that. Now we got a nice slider to control the extrusion. So if we want to reverse that, we just need to subtract this division by 1. Now the clusters are getting thinner on the top and bigger at the base, so that's pretty cool. Now let's say we'd like to add an extra control for remapping the values. We're going to create a control ramp that we're going to call remap, and it's going to control this division thing. And now as soon as we tweak the spline, it's also affecting the extrusion based on the height. So that's pretty nice. So yeah, that's pretty fun to play with. Okay, let's say it's good. So to sum up, we got a remap function of the position cluster divided by poseref. We reverse that with a 1 minus this operation, and we multiply the whole thing by a multiplier called extrude mult. And if we want to make it clean, let's declare the extrude attribute as a float. Now, if we play with the amount of chunks and clusters and things, we can get some pretty cool thing. I kind of think that it's more interesting to keep some pretty low values in general. I'm gonna call that attribute extrude control. Tweak a bit the extrude and noise. So that would be a good low poly base to work with. So now let's see how we can high res this guy. So I'm gonna create a null crystal high res to start with, and we're gonna subdivide a bit this guy. So I'm dropping a subdivide and increase the crease weight and the depth to something like around 5. So we need to break up a bit these edges. So I'm gonna create a group expand to isolate the top. That will allow us to protect it from the operation. So I'm increasing the steps values just to make sure we are covering all the faces of that cluster, and we're gonna call that top group expand. So I'm blasting this guy, top group expand. Let's duplicate this node and delete non-selected. All right, so we're gonna work on that one group, and we're gonna create a transform. So I'm increasing a bit the height. Okay, and we're gonna mix those two positions with a point VOP. So I'm diving inside, and if you know how I work, well, you probably already seen that. I'm importing the point position of the first and second input, mixing that together with a mix node. Let's set that to second input, and as soon as we change the bias, we are switching from one position to another. Now the cool thing is that we can control the bias with a turbulence, and I usually like to fit range this guy and contrast it a bit by changing the source min and source max. So let's reduce the frequency. All right, okay, it's getting better. Can add a bit of roughness, and let's increase the frequency actually. Okay, that's already looking much better. Of course, we can always tweak the transform to give more or less amplitude to the effect. So I'm gonna make some bit more changes. Yep. Yeah, that's not so bad. I'm gonna merge back the top crystal, which was in quarantine for a bit. Okay, I like to get it a bit thinner. So one thing, at the beginning of this setup, with the top transform, we could center the pivot to the center of the group with $GCX, GCY, GCZ. Thanks to that, if we change the uniform scale, we can make the top thinner. At the same time, let's try to give it some more height. It's pretty cool. I'm gonna change the seed of the scattering just to give some random result. Cool, I kinda like that shape. Now, if we look more closely, I forgot to turn on the extrude output back. So one other way would be to use a polyfill to close the geometry. Now that the geometry is close, we can turn that into a volume with a VDB from polygons. And I'm gonna set the voxel size to 0.005, will depend on the scale of your project, of course, and convert back to polygon. So it's been fusing all the different clusters into one mesh. So that's great. We're gonna do some operation. Let's rename distance VDB to density and fill the interior. We're gonna drop a volume VOP and dive inside. So let's drop a AA noise, anti-alias noise, and multiply it by the position. So we got some kind of weird result, like if it was peeling skin or something. And I'm gonna use a fit range to get rid of that effect. So as soon as we change the source min and source max, we reveal how much you wanna reveal or not. One thing we could do is play more with the frequency. Something like that. And to give some more randomness, I kinda like to plug a trigonometry function in before the position. And let's maybe try sinus and increase the frequency. So we got some pretty interesting result. And then I gonna mask that with a turbulence. So I'm adding a turbulence, a fit range, and I'm plugging that in the source max. So I'm gonna contrast it a bit. And let's try to play more with the frequency. Maybe can stretch the noise. So before and after, if I replug. So it's making the effect just less extreme, and I think that's a bit more subtle. So what we could do to fill the interior would be to add a VDB reshape and set the operation to erode. By playing with offset, we are controlling how much it's eroding the volume, and we can mix it with a volume mix with our volume VOP, changing the mix method to minimum. This way we are avoiding holes in the geometry. Let's compare before and after the turbulence. Yeah, I'm pretty happy with that. Maybe play more with the frequency. Cool. Let's add a bit more resolution by decreasing the voxel size. So it's a little sharper, but now we could also tweak a bit the offset, and that's what we got. So I'm gonna promote a bunch of parameters just to make the whole setup more user-friendly. And we could organize things into group. So that would be for the turbulence. This group is gonna be for the AA noise. Wonderful. Also, I don't like keeping that name. I'm just gonna rename that min input and max input. So that one too, we're gonna rename that edge breakups and promote all the turbulence parameters again. Same deal, I'm creating a group, putting everything in there. Min input, max input. It's nice and clean. Let's create a network box for this high-res part and another network for the cluster. So extrude cluster. Let's apply a color at the end for the high-res. And a color for the base shape. At the end, we're just going to create a null. We're going to call it output crystal. Okay, one thing we didn't do is actually optimize a bit this guy. So if we change the adaptivity we get a lighter geometry with less polygons, and as you can see, we only got 200k points. I'm saying only, but it's considering it's high res, so still better. And that's pretty much it for today, guys. So that was the main technique I used to generate the main crystal of this mineral. To tell you more about the rest of this project, you can head to my Gumroad page and find the next videos inside the project Fibrous Malachite tutorial series. Right now the price is really low. I only have the part 1.5 and part 2 ready. The idea is that I will increase the price as I am recording and adding the next parts of the tutorial. So the sooner you get the project, the cheaper it is. And you will of course receive all the updates for free, which is, considering what's coming next, a very good deal. I may upload later on my YouTube one more free videos about the rendering in redshift so that everyone can benefit some knowledge about this awesome plugin. Don't forget to subscribe if you don't want to miss that. In the meantime, stay awesome and see you guys either on Gumroad or on my next videos.